Hello. This is linear equation 6.7, linear systems. A linear system is two or more lines that are considered at the same time. So if I have a problem, a word problem, or a situation where I'm going to get two or more linear equations or two or more lines, I'm going to actually consider them at the same time. Now, the point at where they cross is called the point of intersection. And this is where those two linear equations are equal. And I can solve this by two methods. First method is I can graph them out and I can visually see where they cross. It's not exactly going to be the best method to do this, but I can physically see where they cross. Sometimes it could be obscure, but sometimes not. But if I graph them out, I can get a very good idea of where they cross. The second method, which is much more exact, is algebraically. And in this case, I'm going to compare those two lines and I'm going to solve for the point of intersection. In addition, I can also verify any result I get either by graphing or by algebra, and I can substitute that into one of the equations, and as long as I get a true statement, I know that I did the method correctly. I know that I have the exact point of intersection. So let's take a look at an example. The first example is I want to identify the point of intersection between the lines y equals 2x plus 4 and my red line y equals 3x plus 1. So the first thing I'm going to do is I'm going to plot my blue line. So I'm going to start at the y-intercept for the blue line, which is 0 and 4. So I go up to 0 and 4 here, and I'm going to make a dot. My slope is a rise of 2 and a run of 1. So I'm going to go up 2 over 1, then go up 2 and over 1 again, and even go a third time. So I'm going to have 4 dots in a row, and that's going to be my line. So I'm going to use my line tool here. And, let's make it this one. And I'm going to go from here all the way and through each of the points, like so, like that. So that gives me one line. Now my red line, I have a different y-intercept. It's plus 1. I'm going to mark that off as my red dot. But my slope is now a rise of 3 and a run of 1. So rising 3 over 1, rising 3 over 1, rising 3 over 1, and again, rising 3 over 1. Again, I'm going to use my line tool. I'm going to make this, I'll make this still black. And I'm going to go through here and go up here. And from inspection already, I can see that I have a point of intersection right here for my two lines. And it is going to be 3 and 10. So that's my point of intersection. So I figured it out at 3 and 10, that is where my two lines cross. So I solved this one graphically. So I graphed both the lines, saw where they intersect, so saw where they crossed over, and that was 3 and 10. Now my second method is algebraically. And I'm going to use the same exact two lines. I'm going to say it's y equals 2x plus 4 and y equals 3x plus 1. Now algebraically, I notice two things. I have two equations, and I also have two unknowns. I also have y. Y is going to be the same for either equation. So y on my blue line, so I'm going to put it B, it's going to be equal to the y of my red line. So that means that what they're equal to will also be equal. So I can just plop in my blue part of my equation, 2x plus 4, and that's equal to 3x plus 1. So since the y's are equal, then both of these parts of the equation are equal. From here, I only have one variable, x, so I have to solve for it. So first thing I'm going to do is I'm going to collect like terms. So I'm going to move this 3x over to this other side. So subtract it here, and also on this side. So 3x minus 3x is 0, and I have negative 3x plus 2x, which leaves me with 1x. Then I'm going to move the 4 over to this side. Same deal. Subtract both sides. Negative 4 plus 4 is 0, and 1 minus 4 is going to be negative 3. I'm left with negative 1 here, so I have to divide both sides by negative 1. And for my x value, I get 3, which is great. So I get 3. So from here, I just choose one of my two equations, and I'm going to choose the blue equation. So y equals 2x plus 4. And I'm just going to substitute this x equals 3 value into the equation here. So y equals 2 times 3 plus 4. 2 times 3 is 6, plus 4, so I get y equal to 10. So y equals to 10. So right there, I've now algebraically identified my point of intersection. It is going to be 3 and 10. So I got 3 here, 10 here. So my point is going to be 3 and 10. I can now verify this by substituting this point into the other equation. Oops. So my red equation was y is equal to 3x plus 1. So I'm going to sub in I'm going to sub in (310), see if I get a true statement. So I have 10, 3, 3 plus 1. So 10 is equal to 3 times 3 is 9, plus 1. 10 equals 10. That is a true statement. Therefore, my point of intersection is correct.